Dr. Nick Gabler received his PhD from La Trobe University in Melbourne, Australia in 2015. After conducting postdoc research at Purdue and Iowa State, he joined the Department of Animal Science faculty in 2008, where he is now a full professor. In 2021, he was appointed Associate Department Chair of Animal Science. Dr. Gabler has a successful teaching and research program in swine nutrition and physiology. His research program focuses on understanding and improving swine feed efficiency in growth, and he utilized both basic and applied cellular and whole animal approaches to provide industry solutions. Please welcome him to the podium.
Thank you, Cassie. So good morning, everyone. And thank you to John and the organising committee for giving me this opportunity to talk about probably their last 10 years worth of research that we've been done. So a lot of the stuff I'm going to present is actually the lessons that I've learnt and then what I've seen with my group, and then also I'm going to put some future thoughts into this. And I would say this is probably one of the most challenging research areas out there that I've had in my 25 years of doing research, because to be honest, 90% of the things that we've tried, even 95, don't work. And when it comes to actually feeding a disease-challenged pig. And so that's part of the problem, because there's so many nuances, and we'll get into some of that. But really, we've heard from the last probably day and a quarter that digestive physiology, gut health, and other aspects all are important for actual lean tissue accretion. And one of my pet peeves is, and we heard this morning, is that people talk about gut health. But it'd be really helpful if actually people define what they mean by gut health when they actually start talking about it, because gut health can mean many different things. And so when we're talking about gut health, we need to make sure we're talking about the ability of the pig to either be resistant to enteric pathogens or disease. Also, can it improve nutrient digestibility and availability to the host? And so when we talk about gut health, and it's in generic terms, it absolutely means nothing, because it's a pointless kind of generic term. So I would encourage everyone, if you're going to talk about gut health, please define what your definition is, because without that definition, we're never going to move forward. Because we heard from this morning, there's no kind of normal microbiota. If we're talking about a stable microbiome, what's normal? There is no normal in the sense, depending on which part of the world you go, but it is very important, and it actually interacts with how the host and pathogens interact. But today, when John asked me to give this talk, he said, I can define stress and disease or whatever I like. So I'm going to talk more about the disease side of work that we've done rather than weaning, stress, etc. But when we talk about disease in the center here is really the expression of how a pathogen interacts with the host. And it's in really the pathogen, conductive environment, which is facilities management, susceptibility of the host, all come together to have disease. And we've got to remember, when we talk about disease, we can have clinical and subclinical disease. Quite often we see in our production systems that pigs may be subclinical, but yet there's an underlying factor there that actually is exacerbated due to an off-feed event, due to a change in dietary phase, that then expresses itself then to full-blown disease. So sometimes when we're talking about feeding pigs, we've got to also talk about feeding subclinical disease states. And that's often not necessarily discussed. So for the next couple of slides, I think this sums up everything. Nutrition by health is complicated. There's no straight answer to it. And I think we're kidding ourselves if we're saying there's a straightforward answer, one size fits all, because there's so many nuances with regard to nutrition by health, or even health in general. So we can, as I said before, we can have subclinical to clinical disease presentation. You can have differing isolates and virulence. So in other words, we're talking about PERS. We've used about 4 different PERS isolates in our research studies over the past probably 10 years. And then, it could be a 118.4, 134, 174, then you've got the 144 right now, and each one of them is going to have a different impact on the pig with regard to a growth phenotype and also a actual disease presentation phenotype. You talk about E. coli. We hear a lot of talk about E. coli, but depending on the toxin presentations on that hemolytic E. coli is going to dictate how severe that E. coli actually is. So E. coli isn't E. coli, flu isn't flu, PERS isn't PERS, because there's so many nuances within different isolates and virulence. And so until we start reporting on this is what we're using, especially with the E. coli field, this is the E. coli that we're doing our challenges with or what we're seeing in the field, and these are the toxin presentations, it's very hard to match up what's working and not working. Also, we've talked about stress and pathogens. It can result in body weight loss, but then different degrees. We can talk about a loss of body condition score on the extreme side, but that's when we actually get to the real kind of clinical aspect. But quite often we only have a static or marginal growth response. In other words, a pig can be susceptible or be inoculated with a pathogen, and then this is a growing pig, but it can just have static body weight. So it's not losing weight, but it's not gaining weight. And that's going to depict on how well these pigs are going to perform long term. And also, there's an aspect of compensatory gain. And what we've seen is that depending on the type of stress, which is going to be a factor of severity by duration, we can have pigs that will respond to compensatory gain. So quite often in the nursery, what we've seen that if we have an accidental swine influenza occur in the first 2 weeks of the nursery, by weeks 3 and 4, those pigs have caught back up and compensated. However, if they actually have a secondary infection with, say, one of the suises, ASUS, strep suis, along the mix, or even PERS, then we don't see any compensatory gain. In other words, we do have a long-term impact. And so severity and duration are a big thing. And quite often in the academic setting, the severity is either too high because we inoculate pigs with a 10 to the 8 colony-forming units of a very pathogenic E. coli or salmonella. And then the duration, we always end the project during peak infection. So what is the longitudinal aspect of that inflammation or that kind of immune system stimulation? And it's going to have a different result depending on what you categorize as success. So when it comes to nutrition, nutritional products, are they going to be delivered through the feed or through the water? And these can have different practical applications, especially if we're trying to translate ways to better feed a pig. Because you've got to remember, if we have a pet or we have one of our family members or someone goes to the hospital and they're really sick, most of the time they're on an IV drip. So therefore we're bypassing the whole aspect of appetite, the whole aspect of digestion and assimilation of nutrients. And so there's a lot of good technologies out there that can actually, once they get in the bloodstream, they're good, but the biggest translational aspect or hindrance we have is that the pigs don't want to eat or drink, and therefore we can't get those products actually into the animal. And so a lot of the times, a lot of our experience with water is water delivery of nutrients is very good and timely, or products, but it's really good for survivability, but it doesn't really help support much on the growth aspect. And that's good and bad. We talk about carbohydrates, functional carbohydrates. John talked about that yesterday. The speaker this morning talked about different aspects with fibre. They can be pros and cons. Functional proteins. There's been a fair bit of work with methionine, threonine, tryptophan, if we're talking about aromatics. Aromatic amino acids are good for acute phase proteins. The early work by Peter Reed out of Illinois showed that acute phase proteins really like to utilise aromatic amino acids in their synthesis. So can we actually do something in the diet that actually helps with regard to the immune function? Then we've got animal and plant-based proteins. Dean talked about soybean meal yesterday and some of the functional benefits. We also have plasma products. You can put colostrum products, and then alternatives to plasma and colostrum products. These can all be beneficial under different circumstances. If we keep going down the list of functional ingredients, and this is not an extensive list, but just kind of general flavour, we can talk about fatty acids, N3, N6, saturated fatty acids. Depending on the system and the disease state or the stress state, they can be anti-inflammatory, pro-inflammatory, or no effect. And so if you look at the biomedical literature, you can find aspects of all these types of fatty acids can be beneficial or hindering to health. We talk about short-chain fatty acids and butyrate can be beneficial. I mean, at the end of the day, we're trying to get a lot of probiotics or direct-fed microbials to actually produce these short-chain fatty acids to actually help with intestinal health and function, also providing an energy source to the hind gut, which can be beneficial. Then over the last couple of years, there's been a lot of talk about medium-chain fatty acids. On the bench top, medium-chain fatty acids work really great. They're antiviral, antibacterial. You put them in an animal, well, first of all, the animal has to hydrolyze it off the glycerol backbone to make them more available to the bacterial virus to take up for them to truly have an effective function. And so there's opportunities there, but it's how we're presenting it to the pig may be limiting the efficacy of how they're actually antimicrobial. And then we get into vitamins and minerals. We're talking therapeutic and subtherapeutic, or therapeutic versus requirement. This is a big area, especially if we're talking about zinc oxide or zinc. 2,000, 3,000 parts per million, even copper, 200 parts per million, can be very good as an antimicrobial. It also has a growth promoting aspect. And this is one of the issues we're going to have if we do get into the European kind of thinking or legislative aspect with zinc, is what are we trying to find an alternative for? Are we trying to find the alternative for reducing scours, which is the main reason Europeans use zinc in their diets? Are we trying to find a growth benefit that's also associated with zinc oxide that we see, all these therapeutic levels of zinc and copper? And so we've got to be careful if we're trying to start talking about therapeutics, and a lot of companies are starting to talk about therapeutic options to replacing zinc. What are you trying to replace? What's the mode of action? So you got to think about that to actually see whether it's actually going to be a good alternative. Otherwise, like we saw with the antibiotic growth promoters, don't say they're an alternative to antibiotics if they're not promoting growth, because they're not replacing the technology that was there to actually enhance growth. And then we talk about anti-inflammatory products, and then there's a lot of phytogenics, there's some isoflavones, etc. All these have the ability to actually help with inflammation or reduce inflammation, and under different tissues, different kind of parts of the body, can be beneficial at reducing stress and also disease. And then we talk about gut modifiers, where there's direct-fed microbials, probiotics, exogenous enzymes, acidifiers. All these are nutritional strategies that have had, and I would argue a lot of these have had marginal success on a continuous basis in our pig production system. And it struck me this morning during the first talk is that why do things always work with poultry? Well, obviously they come in pretty sterile, their digestive tracts, and so they're inoculating them with exactly what they want, where we don't have that with the pig. So there's some nuances there that why a lot of this stuff doesn't actually translate over to pigs. But really, this is the big slide for me. And so I was challenged with this about 10 years ago. Well, okay, one, we talk about challenge models. Do we use a endotoxin LPS model? Do we use a salmonella, E. coli, a virus of some sort? But then how do you gauge success? How do you know that you're actually going to use something in your diet formulations or management strategies and gauge success? And so for me, in my opinion, this is all my opinion here, my opinion is that you could gauge success in 3 different categories. One is just prevention, treatment, and recovery. And so depending on the mode of action of the different products that you use in your diet, they could be targeting these 3 areas. And with that, success is going to fall into these 3 categories. Is it improving survivability? We've done a lot of work with, we've done some work, not a lot of work, with delivering water, delivery of nutrients and also other products to the pig, especially the nursery pigs in the face of PRRS. We've done some work with PEDV, rotavirus, E. coli challenges, etc. A lot of the times that water delivery doesn't do anything, doesn't move the needle when it comes to measuring performance of those pigs. However, survivability can be improved. But the problem in academic settings is that when we talk about survivability, we need to really work with our industry partners because we just don't have the sheer number of pigs to actually pick up significant differences or major differences in survivability if you only got 100 pigs or less on it per treatment. But really, a lot of the water technologies actually are really good at survivability, keeping that pig alive and keeping it going. But also, we've got to make sure that if we are improving survivability, at the end of the day, we end up with a viable pig, a pig that can make it all the way through to actual market. Like probably 6-7 years ago, my mum was in the ICU, and she was plumbed into every single medical device possible. We kept her alive, but if she actually survived that, then her quality of living wouldn't be good. So she needed all this artificial. So we've got to make sure that if we do improve survivability, we end up with viable pigs, and it doesn't become a welfare burden or an actual economic burden to actually keep them alive. And this is the trade-off that we have. But performance in our studies, most of the aspect of success that we're gauging is either survivability if we can, but it's really the performance aspect. Because at the end of the day, under our circumstances, we can do performance measures quite well with regard to different pathogen challenges. We can measure the feed intake, the feed efficiency costs. And then for many years, our whole philosophy is we need to know more about feed intake and feed efficiency with regard to actual pig production under different pathogenic stress. We have a good idea on growth rates, but then not much of an idea on how is it impacting actual feed efficiency and feed intake. Another way you can measure success is reduce scarring or look at diagnostic results. Do you improve your CT values? Do you improve your cultures if you're looking at colony forming units? Then that could be that's interesting. Reduce inflammation is another thing you can look at. But then without putting this in combination with survivability and performance, it's pretty kind of arbitrary in the sense, yeah, it's great, but a CT value or a colony forming unit does not always translate to differences in actual performance or differences in survivability. So when companies come to you and say, hey, I got a product that can increase our CT values from 20 to 25, well, with PERS, they're still positive. They're still shedding virus, and they could have the same reduction in growth performance. Or the same thing with PED. Or even, there's always rotavirus or hemolytic E. coli being shedded. You can always pick it up in a culture model, or at least in a culture process for the D lab, but is it actually impacting performance and survivability? And so success would be a combination of these three things. And it's like anything, if we want to see if something works, we need to define how we're going to gauge it actually working. What is success? And that's probably the biggest thing that I want to challenge everyone is up front, tell us. We think this is going to be successful if we can improve growth performance, survivability, because quite often we don't see that. So really, at the end of the day, we're in the protein business. So we're doing most of our work with growing pigs. So we're interested in how does that pig capture nutrients and then assimilate that into lean tissue. And it's been widely known for many years now that pathogenic stress or disease impacts growth potential. There's an altered metabolic demand and reduced efficiency of the animal. All right, so as I said in my opening comments, probably 95% of the things that we've tried haven't worked with regards to growth rates or feed efficiency or feed intakes. But I will share 2 or 3 examples of what has worked. And then off record, I'll tell you what hasn't worked. But really, one of the greatest successes that we've had is in collaboration with Dr. Eric Burrow at our veterinary diagnostic lab, where he's an expert in swine dysentery or brachyspire hyodysentery. And we've explored some nutrition by disease interactions with this particular pathogen. Particularly, we're focused on fibre. And so work from Australia and Europe have really shown that reduced incidences of swine dysentery when diets are fed that are more highly digestible, particularly with highly digestible fibre. And so if you have a decreased digestible fibre in the diet, and we can get into debate of what we're talking about with regard to digestible fibre, we can have differences in the incidence rate of disease. In particular, for the North American industry, actually, this is Dr. Patience was part of this with Eric and Dr. Wilberts. but really they showed there was an interaction between feeding distillers grains, corn distillers grains, with actual swine dysentery. And so we wanted to follow that up and see, okay, well, what's actually going on? And actually we stumbled upon this because Wes Schwer, part of his PhD program, was interested in seeing what the endogenous losses of amino acids were if we gave a pig swine dysentery. We had some T-cannulated pigs, and so with John, Wes challenged them with swine dysentery with Eric, and then what we saw was in these pigs that if we fed them a high cornstarch diet, in other words, a low nitrogen diet, we actually decreased the scouring and disease presentation in those pigs. And so we thought, okay, well, let's try something with actually changing the diet structure. So we just put in beet pulp and a resistant potato starch, and you can see that we had improved. This is our negative control, positive control that was challenged, and this will be our positive control with our changes in our starch and beet pulp. And we can see that we were able to maintain some growth rates, able to maintain feed intake, and then we had a positive impact on digestibility under this. So in other words, during peak dysentery infection, we had about a 70 to 90% kind of reduction in growth rates if we're comparing our positive and negative controls. And this can be mitigated to some extent by just changing the diet with beet pulp and changing the diet with resistant starch. And so we wanted to take that further and do a titration. And so what we did, we thought, well, let's put in 20% corn distillers and let's offset that with, we just chose 50% potato starch, resistant potato starch, and 5% potato starch and 5% beet pulp, or we just did 10 and 10. And so we had a kind of titration. And we want to know if we offset the diets this dramatically in a stepwise manner, can we actually maintain performance of these pigs if they're all inoculated with dysentery, with brachyspire, dysentery. And so what we can see here, we did this over 42 days. Everything was challenged at 40 kilograms of body weight. But you can see as we increased the fermentability of the diet, in other words, as we decreased corn distillers, we were able to maintain growth rates in these pigs. This was without antibiotics or without any therapeutic minerals or anything like that. This is just straight up using diet to actually manage these pigs. And as you can see down here, we can have positive fecal presentation of brachyspire, and then we can also have a decreased clinical presentation. So in other words, decreased scouring and bloody diarrhea is seen, but yet they're still shedding brachyspire. But this is probably the picture that sums it up the best. This is our 20% corn distillers diet, and this is our 10% beet pulp and 10% resistant starch. This is looking at delta body weights over time. So as they grow through the challenge, and it takes about 7 to 14 days for the challenge to really express itself, we can see that the 20% corn distillers diet, it's actually, their body weight's tanked. But yet we were able to save that by using a more fermentable diet structure. And this is anecdotal evidence, but the D-Lab here at Iowa State does see an increase in brachyspire every once in a while when the production industry puts more pressure on formulating corn distillers in their diets. And so there is a relationship there between at least the dietary fiber content or in corn distillers with regard to swine dysentery. And so this is probably more applicable to an antibiotic-free production system because there is kind of antibiotic technologies out there that can be cheaply and easily utilised. But if you don't want to use antibiotics, dietary fibre content, especially if you make the diet more fermentable and more soluble, can actually have an impact on performance and disease presentation with brachyspire. All right, so the next success story that we had, or what I'm going to talk about, is actually with our PERS challenge models. In particular, I mean, a lot of you have probably seen this, but one of the first studies we did was pork board funded that Wes did with Eugene Gawley, Mark Weaver, Chris Sparks, etc. But we actually looked at lifetime product, or at least productivity from about 34, 70 pounds up to market weight. And pigs that are infected with PERS just took an extra 10 to 14 days to get to market. in this study. But based on this, we want to know, how does PERS alter growth rates and nutrient partitioning in pigs? And so we end up getting some funding from the USDA from a foundation grant, and we want to know, to what extent does feed intake explain the disease phenotype? Every single disease model that we've done, whether it's with a hemolytic E. coli, a Salmonella typhimurium, a PED virus, Lysine intracellaris, PERS, Mycoplasma hyarinus. All the time, one of the main phenotypes we see is always a decrease in appetite or decrease in feed intake. And so we wanted to tease apart, okay, well, how much does feed intake actually explain the growth phenotypes that we see? So that was one of our kind of questions. And also we want to know, what is the energy contribution of actual PERS to the pig? So I'll set this study up. This was one of the few, this is the only study, or one of two studies that we did in BSL-2 facilities here at Iowa State. Everything else we've done has always been in an ABSL-1, or just in a production barn, because our attending veterinarian, Mary, I think somewhere in the audience, but she's allowed us to actually do some of our disease challenge work out in the field, which has been great because we can actually be more translational with the findings that we've actually can get out of this. But really here we end up 3 treatments. So we had a red treatment here, was our PERS infected pig. We had our black treatment, which is our control and PERS negative pig that was actually just fed to voluntary feed intake, whatever they liked. And then we had a grey treatment, which was pair fed or restrict fed, that we actually fed these pigs to the same caloric intake on a daily basis as our ad libitum PERS fed pig. And that would be the grey here. But really what we see is, we've got a nice PERS response here within 3 to 7 days. Normally, if a pig is infected with PERS, within 3 to 7 days, you're going to get a decrease in CT value. And then over time, the CT, as the antibody or as the serology kicks in and antibody titers increase, you start clearing the virus, and therefore you get an antibody response. So we get a nice response in our controlled pigs, and restrict-fed pig, we're actually clean of PERS in both these incidences. And here's our feed intake. We get a nice kind of reduction in feed intake over time. But unlike other models like endotoxin or LPS challenge models and even bacterial models, we can actually get a sustained, this is like 20 days, reduction in actual feed intake over time. We also have an actual difference in body temp. And so our PERS pigs were able to sustain a febrile response. I think Laura Greiner showed some of this work in her PhD, where isoflavones were used, and one thing they could do is alter the febrile response or the fever response. But really, we have a sustained fever in these PERS-infected pigs. But we've also got to remember, not every pathogen or disease state is actually going to induce a fever response. And so it just really depends, because we don't see much of a fever with swine dysentery. But then our control pigs, we just got daily variations. This is probably associated with activity and feed intake. But then our restrict-fed pigs, we actually had a reduction in body temperatures. And that's probably associated with just reduced feed intake and reduced thermal effect of just digestion. And so this is a really nice model. And the endotoxin model is really good, but the problem is it's only for about 4 to 6 hours you got a peak fever, then by 12 hours it's back down again. Then you got to repeat up and down. But this seems to be a little bit more sustained. That's all great, but what about the pig phenotype? So over a 35-day period, we had literally a 50% reduction in feed intake and a 60% reduction in average daily gain, but no alterations in feed efficiency over this period. And you can see the pig here. Here's an ad lib fed pig, and here's our PERS pig. It's on I think it's on the left here, and in the middle will be our pair fed. So it's about a 14 kilogram difference in body weight is what we saw over 35 days. Is how much. Now these pigs didn't lose weight, they just didn't gain weight. And then we didn't see any differences with regard to protein to lipid ratios. In other words, protein accretion and lipid accretion were about the same rate when we actually looked at this. So the question is how much is the energy cost associated with this PERS disease? And then does PERS alter metabolizable energy utilization within the pig? Because we always hear about disease is going to cost energy. Well, can we actually model that out? And so just going off lean accretion, feed intake, etc., really what we see, if we look at maintenance requirements, or just total energy requirements, yellow is going to be for lipid deposition, red's for purple, and the rest is really maintenance and other activities is going to be in the black bar. We can see between our pair-fed and PERS, they're quite similar with regard to maintenance energy intake on a daily basis. So this is ME intake on a daily basis. This is where it's going to be partitioned towards. But at the end of the day, what we see is that there's about 150 kcals per day of ME intake is partitioned differently between PERS and the pair-fed pig. So there is an increase actually within maintenance requirements or how the pig is utilising that over 35 days. But if we did the same study and ended it at day 14, when we had our peak fever responses, it's probably going to be about 3 to 4 times that maintenance requirement. And so this is one of the troubling things that we have with disease research is when do you start and end your interpretation of what's going on with regard to energy utilisation, intakes, etc., because it changes all the time. Well, that's all well and good, but what's the impact on muscle and growth, lean tissue growth, on intestinal integrity and function, protein turnover, reactive oxygen species, and inflammation? And so probably a hallmark of what we always do, we always have a disease phenotype, like a Feedham-Wayham type phenotype. Then we always try and go to lean tissue accretion, because that's what we care about, is muscle mass and what's going on with regard to muscle with protein synthesis and degradation. And then we also do a lot of work trying to understand what's going on with intestinal function, whether it's digestibility, intestinal integrity, nutrient transport, etc. And so we looked at this extensively in PERS. And I could tell you what PERS does to pretty much every organ in the body based on the 10 years of work that we've done. But really, what's it doing? And so this is some work that Wes did with regard to endogenous losses. But we see over time that there's a decrease in SID values of arginine and proline. Endogenous losses are increased for total tract nitrogen at DPI 7 and 8, but then it's whitewashed out when we get to the end of kind of day 21, or day 18 to 20. And so we have a decrease in endogenous losses of arginine, alanine, proline early on, but not later on. So this is when we get into, is there some benefits of soybean meal that Dean talked about? Well, it could be because we're focusing in on different amino acids. And so really what we did is to understand what's going on. This is just literally the loin muscles that we took out of our pigs. Here's our ad lib, pair-fed, and PERS. You can see the big differences. But is there differences in protein synthesis? Is there differences in other things going on within this during peak infection? And so Emma Helm did this work, and really we see with regard to the liver and muscle of these pigs that liver glycogenolysis markers are not increased with regard to PERS. We look at muscle mitochondrial reactive oxygen species production and is not elevated with PERS. We always assume that there's increased oxidative stress going on. We always assume that there's increased proteolysis going on in lean tissue, and it's partitioning it away from, amino acids away from lean growth towards the immune system. The evidence that Emma has shown is that we are not seeing any proteolysis pathways that are upregulated with regard to PERS. And these pigs were not growing, they were actually losing weight, even compared to the pair-fed. What we did see is when we look at the protein synthesis pathway of mTOR, there are markers that were decreased in PERS. So this would indicate it's really a nutrient supply that's antagonizing lean growth potential of the animal, not necessarily protein turnover. And this kind of changes how you kind of interpret some of this stuff, because a lot of times we're trying to reduce inflammation, we're trying to alter proteolysis, but really it seems to point towards a nutrient and energy supply issue with regard to protein synthesis rather than a increased turnover issue. And we looked at kelpanes, kelpostatins, ubiquitin proteasome pathways, autophagy pathways. We looked at every single protein or proteolysis pathway we could think of, and we don't see any indicator that PERS is increasing that in lean tissue of pigs under our model. And most of this muscle phenotype is actually just a function of feed intake and caloric intake. That's probably the take-home message that we're seeing so far. So what about intestinal function, intestinal integrity? And really what we're seeing is that digestive function and nutrient availability or nutrient absorption is unchanged in the PRRS infected pig. In other words, machinery is all there, it's just purely a supply issue. How well they're going to digest and assimilate it seems to be the impact. There is a partial reduction with regard to intestinal integrity, measured by the way we did it. And a lot of the intestinal integrity, in other words, leaky gut issues associated with the pig, seems to be described by the disease hyperphagia or reduced feed intake. And so one of the biggest things that we see with regard to intestinal integrity changes in a pig is feed intake, as it gets closer to maintenance requirements, is actually having a big impact on intestinal integrity, whether it's a small intestine or large intestine. And then that explains a lot of the functions that we see, at least in the PRRS model that we've had. We see the same thing with Lysine, swine dysentery. Same thing when we feed pigs to maintenance requirements. We're altering intestinal integrity as we do that. All right, again, that's well and good. It seems to be the appetite, feed intake or caloric intake explains a lot of the phenotype that we've assessed in PRRS. So what can be done? And so we tried to do some stuff with water delivery, make it translational. So we've actually, this is work that Blair Todd did for a master's program. We fed a B12 sodium salicylate combination. We used tonicity product. We had PRRS infected pig at control. So this was tonicity challenged, B12 sodium salicylate challenged pigs, or challenged with PRRS. Can we actually drive feed intake or decrease the fever response in these pigs? If we can reduce that febrile response, can B12 actually stimulate appetite, which is what some of the anecdotal evidence would suggest it could do? Can we actually rescue that pig? In a nutshell, none of these technologies that we can use plumbing to the waterline actually did anything with regard to body temperature or feed intake. However, this is very small numbers, and it takes a word of caution, we did improve survivability. So I said up front, using water delivery of products, whether it's isotonic solutions, electrolytes, whether it's sodium salicylate, etc., we can actually improve survivability, but we're not moving the needle with regard to pig performance that we've seen. And we've done stuff with PEDV and seen similar things. We can improve survivability, but we're not doing anything with regard to performance parameters. So then, really the only success story we've had so far with actual PRRS challenge models is actually looking at lysine to energy formulations. And so, Noel, you got a plug yesterday, but some of your work with lysine, also Claysen's work suggested is an amino acid relationship. And so what we want to do is that, can we actually change the diet if the pig has a 20 to 50% or 20 to 60% reduction in caloric intake? Do we see a benefit? And so I wish we did all of the early work, but really, I'll get a little time, aren't I?
Running a little close.
All right, run a little close. All right, I'll go up to this. This is Jessica Jasper's study, but Wes did all the breakpoint work. But really, what we're seeing is that if we increase lysine to energy levels at the point of when we actually inoculate pigs with PRRS, under 10 to 20 pigs or 10 pigs per pen, whether they're vaccinated or non-vaccinated, over a 6-week challenge period, we can maintain, or at least rescue growth rates. And we can achieve it through two different ways. Either we can increase the amino acid to energy ratio, in other words, increase the amino acid component to energy, or we can dilute energy. So we used an inert, this is the sand pigs that everyone refers to, but we fed pigs sand to dilute energy by about 20%. And when we diluted energy in these pigs actually ate 20% more. So these pigs were eating to their energy needs during a PRRS challenge. And we were able to rescue pigs with regard to growth performance. So we're getting, over a 6-week period, we're getting anywhere from like a 4 to 8 kilogram difference in body weights. And so, but also, we want to build on this because there's got to be a practical application. And this is what we found didn't work. If we use soy hulls or fiber to actually dilute the energy, as John alluded to yesterday, we didn't have an impact we impacted feed intake Therefore, we couldn't get the concentration of nutrients in the diet. So using 8% soy hulls to dilute the energy to increase our lysine to energy ratio by about 120%, we found out it didn't work. The other thing that we did, Jessica Jasper decided to go inoculate 200-pound pigs with Mycoplasma hypomoniae. It didn't work when we did it under a mycoplasma challenge. So that ratio, changing that ratio to 120% didn't work with mycoplasma. And then we want to do a more practical application. So what if we didn't know the pigs were going to break with PRRS? What if we came at 21 days post-infection and then we altered the diets? Will that work? And so Kayla Miller on a current IPPA-funded project tested this. So when we came in at day 21 post-infection, and then we implemented either 115 to 130% increase in lysine to energy, we did not have an impact on growth performance in these pigs. And so really this suggests that if we are going to have a play on the amino acid energy ratios, it has to be at the point or close to the point of infection. And that probably makes sense. That's when all the acute phase proteins, all the immunoglobulins and cytokines are all being produced. And so that's where we can actually have the benefit. But it doesn't work if we go downstream from that. So it seems to be that somewhere in that 3-week window post-infection is where it works. So this is where it comes into some translational issues of how do we adopt some of this stuff into the field? Because it's not necessarily practical because you don't know when your pigs are going to break with PRRS. And so really just to kind of sum up, because I'm running out of time, the biggest take-homes that we're seeing so far is that pigs will eat to their energy needs even when they're sick. I've had USDA reviewers say pigs don't eat to their energy needs if they're sick. Well, here we've seen that they do. Diluting dietary energy increases feed intake, and so therefore we can rescue and support this. So really I'll skip over some of this, but how much time have I'm over? You're over. All right. Well, some future thoughts here is that there is the ability to play on the nutrient specs of the diet. And then the problem is that we actually formulate diets based on the assumed feed intake. And so what we've seen as being successful is that if we know how much our pigs are reducing their feed intake by, can we actually concentrate up those nutrients in that diet to therefore every mouthful they do eat, if there's a 20% reduction in feed intake, if we have 20% more of those amino acids or vitamins and minerals coming in, we can meet their needs better that way. And that seems to be a practical application that we're exploring, because by concentrating up on what we think the disease is going to do with regard to feed intake, we seem to be able to support the pig's immune system and also its growth potential. Some other things that John asked me to put some thoughts in. I'm running out of time, but really, at the end of the day, improved biosecurity and whole herd health is the biggest thing. The biggest issue is we get nursery pigs that the problem's already been set up at the sow farm for them to fail. In other words, they're coming in with rotavirus, A and C, they're coming in with hemolytic E. coli, even some strep. And so I think we need to really focus on sow farm health and then how that's passed on to that nursery pig. If we want to improve performance of a first week of a nursery pig, those pigs are only going to be eating 50 to 150 grams a day. We may not even be getting enough of those nutrients or that bioactive compound into the pig to actually have a benefit in the first week. And so there's opportunity to target more late gestation, lactation for early nursery benefits. Compensatory gain, as Kansas State, Mike could probably tell you, it's all over the place. Sometimes it works, sometimes it doesn't. It depends on the severity of the stress and the disease. So I've run out of time, so thank you for your attention, but I'd like to acknowledge all my students, past and present. Some of you are here, but really, hopefully this work is translational, and the whole idea of what we try to do is, like other universities, is provide you with opportunities. So here's where we think the opportunity is, and we'd love to hear if some of this stuff actually works in the field. So for that, I'll take any questions.
So we do have a few minutes for questions for our speaker.
Nick, nice presentation. Thank you. I wonder if you pair-fed the PERS challenge pigs to the level of the control, meaning you had to hyperalimentate them, whether you would see what you think you saw in that trial?
Good question. So we actually, we're currently got a grant with the USDA under review that we actually want to do that. Because there's rodent data from the 70s with listeria that if you force feed rats or mice with listeria, you kill them. So it actually is detrimental. But then that's with bacteria. And so I think there's a nuance between bacteria and viral pathogens that you could probably get away with it with virus. You may not be able to get away with feeding up to 100% of normal healthy intake, but you may be able to close that gap. And so we'd like to actually do some of that work. And I think that's where the future is how much can we push that physiology, because the hypothalamus overrides everything with the pig. It has no desire to eat, no matter what flavors, no matter how palatable the diet is. If they're sick, they just don't want to necessarily eat.
Yeah, we always blame it on the fact that they won't eat, but is growth driving feed intake, or is feed intake driving growth? And so you'll have to do that hyperalimentation to get the answer to that question.
Yeah, it's like chicken or the egg.
Great question, Dan. That was going to be mine. Nick, just real quick, there are some functional proteins out there that have shown benefit on the mTOR pathway. Any thoughts about using one of those to stimulate that mTOR pathway even with lower intake?
All right. You have to tell me the particular protein I can...
The beta-grow product.
Okay. I think if it gets into the animal, first thing it's got to get into the animal. If it gets in, it has potential. We've tried stuff with branched-chain amino acids. Like we did a nursery study they came in naturally with Rota A and C and Hemolytic E. coli. We increased our valine and isoleucine concentrations or ratio to lysine by 130%, thinking that those branched-chain amino acids would stimulate mTOR and stimulate thus protein synthesis and growth rates. But we didn't see that. But if you trace back to where, at least on the branched-chain amino acids, and I don't know if Mike's going to touch on that this afternoon, but the Baylor work that showed that mTOR signaling was actually implemented with branched-chain amino acids is actually under protein-deficient diets, is where they saw the benefit. If it was protein-sufficient diets, they didn't get an mTOR or a protein synthesis response. But I think there's lots of different technologies that can target mTOR, but the problem is that most people haven't actually measured that actually in the pig. Is mTOR actually being targeted? In culture, in biomedical studies, the technology's there. How it translates to the pig seems to be hit and miss. And so I think with the Better Grow product or some of these other colostrum alternatives, I think we need to see, is it actually turning on protein translation initiation through mTOR? And it hasn't been done yet.
Thank you, Nick, for the presentation. Pedro Urriola, over here.
Right, where are you? Oh, yep. You'll say it, yep.
Yep. So, Nick, I remember some older data in mice, and I think Kirk Clason with chickens too, in which, if I remember correctly, increasing feed intake during the disease actually resulted in greater mortality, because there seems that the decrease in feed intake was protective or improved the survival of the animals during the acute challenge. And I wonder, your data is different from that, and I wonder
Yes.
What could be that different? Are there moments where, yes, decrease in feed intake may be protective to the animals?
Well, I think that relates to, I think it was Dan's question, the first question I had. I think in pigs, we really don't know how far we can push feed intake under bacterial or viral pathogen load. Most of the mortality that's been reported in the biomedical literature with rodents, etc., has been always under bacterial infection. Yeah. And there's been some work that they can you can alter oil and protein, or at least fat and lipid and protein, with viral challenges with influenza, and there's been no detrimental effect on survivability. So I think there's a nuance between bacteria and viruses that can be explored. I'd be more hesitant on the bacterial side, where there would be an increased mortality or decreased survivability, but I think there's opportunity on the viral side. But in pigs, that hasn't been done yet. And then 80% of the stuff that we see in biomedical literature doesn't translate to what we always see at the slat level. I mean, there's concepts that are absolutely correct, but the translational aspect, we just don't see it.
Thank you.
So we do need to move on to our panel, but if you have any additional questions, Dr. Gabler, I think will be around, so please help me thank him again.
Thank you, everyone.